So we have this displacement time graph. This graph is such that the motion is like this. Then goes like this and finally comes here. The time intervals we have, this is T1. This is T2. And this is T3. I want you to help me analyze this motion. Help me analyze this motion. Okay, Abbas. Abbas, bring the eyes for us.
So please, this means that the person traveled a certain distance for a period of time.
Abbas, hold on. Instead of a person, use a body, okay? A body or a passenger.
Okay. Okay. So please, a body moved in a certain distance for a period of time.
What is the period?
And later,
what's the time here?
T1.
Okay, go ahead.
And later came to rest for a period of time, which is T2. And later came back to its destination, which is in a period of time, which is T3.
Okay, thank you, Abbas. Another contribution. You are 60 here. Yes, another. Farida.
Sir.
Let me hear from you.
Within the time interval T1, the body went through uniform velocity motion. Then from T1 to T2, the body was stationary. Then from T2 to T3, the body went through the uniform velocity motion to the opposite direction of its starting point.
To the opposite direction of its starting point. Here, I am not clear. So, you see, yesterday I said that the moment I'm coming, so we have a lot to do. So, the moment the graph touches the time axis, it means the displacement is 0. So here, the body returns back to the starting point. Okay? Return back to, if the graph had crossed this, the time axis, if it had crossed the time axis like this, then you can say he came back to his starting point and then further moved away in the opposite direction from his starting point. But the graph just ends at the time axis. So he returned back to his starting point. Class, is that okay?
Yes, please.
So uniform velocity was stationary, and then uniform velocity back to his starting point. That is the meaning of this graph. All right. Oh, the attendance. So add your voice on the page that classes are started. So colleagues must join. If you have the chance, quickly type something for me on the page. Classes are started. Today, let's quickly look at velocity time graph. Velocity time graph. So velocity dash time graph. Velocity time graph. So under velocity time graph, we are plotting the velocity or the speed against time. So V/8 unit meter per second against T/8 unit. Please, we can decide to use different letters, but what must inform you, okay, must be the unit. The unit must tell you the kind of motion, meter per second, and then second. So clearly it means it's a velocity time graph. Are we okay? Let's create, let's use data. So V meter per second, T/second. When time is 0, motion has not started, so velocity is 0. When time, Davis, please stop using my board, okay? Leave the board for me for now, okay? So 0, when time changes by 1 second, this is 5, 2 seconds, this is 10, 3 seconds, this is 15, this is 20. Let's end at. So when we plot such values, 1, 2, 3, 4. So 0, 1, 2, 3, 4. Our velocity axis, we have 5 units interval or 5 meters per second. So 5, 10, 15, 20. Pascaline, leave my board, okay? So let's plot. Time of 1 second goes with velocity of 5. 2 seconds goes with velocity of 10. 3 second velocity of 15. 4 second velocity of 20. So if we join the straight line, we have this. Let's find the slope. Let's find the slope. I'm picking 2 points. Help me find the slope of these 2 points. This one, then this one as well. The final and then the first. So help me find the slope of this 1 and slope of 2. Dennis, are you done?
Yes, sir, I'm done with the slope of 2.
What's your answer?
Sir, please, 5 meters per second.
Are you sure? 5 meters per second?
Yes, sir.
Your unit is not correct. Jedediah?
Yes, sir.
What's your value of the slope?
5 meters per second.
It's not 5 meters per second. Evans, let me hear from you.
Sir, please, I was going to say 5 meters per second.
No, the value may be correct, but the unit. So, Russell.
5 meters.
Okay, let's see. So For 2, our vertical, so this is delta V on delta T. Okay, so slope will be changed in the vertical divided by change in the horizontal. The maximum V value is 20 minus 0 divided by maximum T value 4, also minus 0. This is 5, but the unit of this is meter per second. The unit of time is second. So the unit becomes meter per second squared. What is the slope of the first one? Slope 1. The slope of the first triangle. Yeah, Jedediah.
5 meters per second squared.
Exactly. You get the same value. The ladies, are you there?
Yes.
Let me hear your contributions. So we'll get the same thing. 15 minus 5 divided by 3 minus 1. 10 on 2, which is 5 meter per second squared. Okay, Evans, is it a question?
Yes, please. Sir, please, the 5 meters per second squared, isn't it supposed to be a exponent -2?
So if I want to bring the second squared upwards, then it will be ms raised to the power -2. But if I want to use a slash, then it will be m slash positive second squared. So that's the difference. Are you okay?
Okay, sir, thank you.
All right. So the key observation is that 1, for a velocity time graph, the slope, velocity dash time graph, the slope or the gradient, is equal to the acceleration of the body. So if you have a velocity time graph and you find the slope is equal to the acceleration of the body. Two, for a velocity time graph, the area under the straight line, this is a straight line. Let me clear the triangle. If we find this area, the area under the straight line, this is equal to, this will give you the total distance covered by the body. For a velocity time graph, area under the straight line, instead of straight line, let me use the graph. Gives the total distance or displacement of the body. And look at this. Look at this shape. Look at this shape under What shape is this? What shape is created under the straight line? Class, what is the shape drawn? And it's a triangle. So if you want to find the total distance traveled, use the area of a triangle, which is half base times height. What is the base? The base is this value. Class, please pay attention and listen. Oh, that is the base. Let me change, deepen it. That is the base. The length of the base is 4. So times 4. Then the height. The height is this color.
Yes.
Please mute yourself when you join, else we'll be recording your laughters. There's the height. And the height is 20, so times 20. Meaning the total distance traveled here is equal to 40 meters. So the area under the graph also gives you the total distance or displacement of the body. Now, when we calculated, we had equal values of slope throughout. We had equal values of slope, 5 meters per second squared, 5 meters per second. So on the straight line, you have same value of slope or acceleration. And because of that, this kind of motion is termed as uniform accelerated motion. So this is a graph of a uniform accelerated motion. Accelerated motion. So class, Pascaline, are you there? Pascaline. Pascaline,
Yes,
what is, help me understand what uniform accelerated motion is. What is uniformly accelerated motion? Just try. It's a trial. What is uniform accelerated motion? Jonathan, leave my board, JJ. Anybody else? What is a uniform accelerated motion? Okay, Farida.
In a uniform accelerated motion, the rate of the change of distance with respect to time is constant.
Farida, you are close, but you are missing something. Your stew is deficient of some ingredients. Okay, let me hear from Emmanuel Teria. Oh, Ishraminta. Okay, Ishraminta. Let's hear from you.
The uniform accelerated motion refers to the rate of change of speed with respect to time is constant.
So in a uniform accelerated motion, the rate of change of speed or velocity with respect to time is constant. Okay. The rate of change of speed or velocity with respect to time is constant. Jeremy, your hand is up. All right.
Yeah, it's when an object's velocity changes at a constant rate.
With respect to time. Jeremy, that's okay.
Yes, sir.
So a body is said to be, okay, a body is said to be in a uniform accelerated motion when the body moves with equal velocity within equal time interval. Okay, so as you can see, the velocity 5, 5, 5, 0, 5, 10, 15, 20, when the time also changes by 1 second. Okay, so that's another definition for uniform accelerated motion. Class, let me drop attendance and then hello and get back to you.
Please, can you repeat your definition again?
I'm coming in.
Sir.
I said in a uniform accelerated motion, a uniform accelerated motion is when a body moves with equal or constant velocity within equal time interval. When a body moves with equal velocity or speed within equal time interval. I want to share attendance on the page, so give me a minute.
Hello.
Hello.
Oh.
It's not clear because of the number. Okay. It's not clear because of the number. All right. So let me get back to you. Okay, so let's resume. So that is it. Now, if the data happens to be like this, the body is moving, but the velocity, the body is reducing velocity or speed as time goes by. So starting with maybe 15. Okay, maybe 12. At time, maybe t is equal to 5, reduces to 10, 4, 3, 3, 8, 2, 6, 1, 4, 0, 2. So then if we plot this kind of motion, velocity of the body against time, V T. So 1, 2, 3, 4, 5. Zero. Then 4, 6, 8, 10. Then I have to, maybe 12 is here. So 12, 10, 8, 6, 4, 2 for velocity. When you plot such a graph, at time 5 seconds, the velocity is, okay, I think it must be the other way around. 0, 1, 2, 3, 4, 5. Okay, so the time must also, usually this is a body decreasing speed. So its speed cannot be 0 at time, okay, t is 0. So it's starting from a final point with the maximum speed. So as the body goes, its speed will be decreasing with time. So at t is equal to 0, the speed is 12. That's it. At t is equal to 1, which is half of this. The speed is 10. 10 is here. T is equal to 2. The speed is 8. 3, 6. 4, 4. 2. At t is equal to 5, the speed is 2. If there is 6, then it will come to a stop where the speed will be 0. So let me include 0 at 6. And when we join the point, we'll equally have a straight line, but this is a negative slope. The slope is negative. Help me calculate the slope of this graph. What do you think will be the slope of this graph? You can pick any 2 points to calculate the slope. It can be this and this. You can choose to pick this one and this one. Any 2. It can even be this and this. You must get the same value. Jedediah. Okay, Aram. It's here, do. Jedediah, let me try Aram too.
Sir, please, the slope is -2 meters per second square.
-2. Okay, that is the observation by Aram. Another hand is up, and this is from Cyrus. Cyrus, what's the slope? Hello, Cyrus.
Sir, please, the slope is -2 meters per second square.
Okay, let's see. So if I choose this, I have there's the final point, 4, minus the initial, which is 10, divided by 4 minus 1. And this is -6 over 3, which is -2 meters per second squared. Okay, if you pick this small one, the slope would be, the final is 0, 0 minus 2 divided by 6 minus 5. The value is still the same, -2. So this one too, you see, the slope is constant. But because the acceleration, the slope of a velocity time graph represents the acceleration. We see the acceleration of this particular motion being negative. So this is also termed as uniform accelerated motion. But because the acceleration is negative, we can also call it as uniform decelerated motion. Uniform decelerated motion. Class, are we okay? Or uniform retarded motion. Similar to what we've seen for uniform accelerated motion. They are all accelerated, but when the slope is negative, it becomes deceleration or retardation. All right. Let me come to your homes. This time I'll call somebody to help me out. And my lens is on Desmond Frimpong. Desmond, are you there?
Yes, sir.
Desmond, I have this kind of motion. This is velocity time graph. The graph looks like this. Desmond, this is also a displacement time graph. And the graph is also like this. Desmond, what is the difference between these two graphs?
So the first one, it's like it uses velocity. Or
That's what I'm listening. The first one.
And the second, yeah, it uses velocity, and the second one uses seconds.
Hey, that's why I don't understand. No. Sorry, I don't understand. Okay, more views. More views. Kwate, are you there? Aram, I'm coming. Nelson Kwate, are you there? Okay, Aram.
Okay, sir, please, the first one is a velocity time graph. And
yes.
then
The second is a displacement time graph.
And it is representing a body that was in motion, but then is now at rest. So from time t, or let's say from t1, it had a constant velocity up until where it is now. And then from that point till the end, which is, let's say, time 3, t3, it was at rest. Same for the displacement.
Aram, partly correct, partly incorrect. Okay, Alexandra.
Sir, please. Hello.
Yes,
Sir.
I'm here.
Please, the graphs mean that at first the body was in motion up to a certain point. So from the body was in motion up to a certain point, then from that point up to the end, the body was stationary and at rest.
So what I'm saying is that I have two different graphs, this one and this one. What is the difference between the graph 1 and 2? More views, about 2 contributions, then we move on. Okay, Ampa, Ampa, what is the difference between motion 1 and 2?
Sir, please, the first one is a velocity time graph. The second is displacement time graph. Now, the first one shows...
Ampa, hold on. Ampa, you are not wrong, but when you say this, you wouldn't get anything in the sense that it has been labeled.
Okay. Yes, sir. I'm getting there, please.
All right.
So the first one shows that the body has been moving at a constant velocity over a period of time. But the second one shows that the body is at rest over a period of time. That's the main difference in the two diagrams.
Okay. And then last contribution from Farida.
Sir, please, in the first, which is the velocity time graph, the body was at rest, but the time was moving, which means the acceleration of the body is 0. And in the distance time graph, the body was at rest, but the time was moving, which means the speed of the body is 0.
So listen to, you are right. The contribution is not so bad, but in simple terms, the difference between motion 1 and 2 is that this is here. This is in motion. Body is in motion. This is at rest. 1 is in motion. 2 is at rest. Yes, as most of you said, the body is moving at a constant velocity, meaning it is in motion. Okay, and in the second one, it's a displacement time graph. If you have slope being 0, it means the body is at rest or stationary. That's the difference between them. All right, is there any question? If you have any question to ask, quickly do that, and let's move on.
Sir.
Hello.
Sir.
Ishra.
Please, can you go over again? The first one.
You see, this indicates that the body is moving at a constant velocity, a constant or uniform velocity.
Okay.
Then in the second one, the slope is 0, and it's a displacement time graph. In a displacement time graph, if the slope is 0, then it means body is at rest, or stationary. Abbas, what's your question, Abbas?
No. Sir, please, for the slope, you subtracted the bigger one, the bigger digits from the higher digits.
Okay, so acceleration is equal to, acceleration is equal to final velocity minus initial velocity divided by the time interval. So the motion started from a higher value and was decreasing. So if we pick these 2 points, if we started from a higher value, 10, and then it decreased to 4 within 3 seconds time interval, this becomes the final, and this becomes the initial. Okay.
Initial.
So the final velocity is 4. Then the initial velocity is 10. So 4 minus 10 divided by time of 4 minus 1. Are you okay?
Yes, sir.
All right.
Thank you.
Welcome. Now, another question. What is the difference between these two graphs? Meter per second. This graph, and then displacement time graph, where we have this. What is the difference between these two graphs, A and B? Anybody? Evans Owusu Techi.
Sir, please, with the graph B, the body is accelerating. But with the graph A, it's in a uniform motion.
Evans, I won't buy it. You are correct to some extent. Dennis.
Sir, please. Sir, please. A is in a constant motion, but B is accelerating.
So be specific. What constant motion? What do you mean? Kujo, Cyrus.
A shows that the body is in motion with constant velocity, whereas graph B shows that the body is accelerating.
The body is decelerating. Accelerating. Okay. And then Abdurrahman.
Sir, please. The A shows that the body is in constant motion, whilst the B also shows that it is accelerating.
Yeah. Okay. Yes. Okay. So A and B are the same graphs. They are the same. This is constant or uniform velocity. This is also uniform or constant velocity motion. Oh, please, when you are giving graphs, check. This is a velocity time graph. And in a velocity time graph, when the slope is 0, it means acceleration is 0. The body is moving with a constant speed or velocity. Then this is also a displacement time graph. And displacement time graph, when the motion is inclined at a straight line, it is a uniform kind of velocity. So the two graphs are the same. They all depict constant or uniform velocities. Please, are you okay?
Yes, sir.
Yes,
so
sir.
this when we come,
Yes,
the
sir.
speed is the same throughout. Here it is moving with one speed, acceleration 0. Acceleration 0 because the speed is the same or uniform. So they are same graphs. Okay. The last graph to analyze is this. Today, I'll give you a lot of exercises on this. That is why I'm taking my time to explain this. We have I'm coming. A velocity time graph. And the graph is this. This is T1. T2. T3. Then we also have a displacement time graph. which is also like this. Let's analyze the graph. Yes. What's the difference between graph A and graph B? Anybody? Wilson, Amuzu.
Sir, please, in the velocity times graph, a body during time frame with uniform acceleration. Then when it reached at the time range between T1 and T2, it moved at a constant velocity. Then from T2 to T3, it was in a state of uniform deceleration. And in B, a body during the time frame of T1 was displaced, was in a state of uniform velocity. Then from the time frame of T2, it was stationary. Then from T2 to T3, it was in a state of uniform deceleration.
Okay, another contribution. Can I have another? Can I have another contribution from a female? Stephanie, are you here? Okay, Shraminka.
For the velocity time graph, the body accelerates from 0 to T1. Then it moves at a constant velocity from T1 to T2. Then decelerate from T2 to T3. And the displacement time graph, the body starts from 0. Then move from 0 to T1. Then it is at rest. While the time is going from T1 to T2. Then it comes back down from T2 to T3.
It comes back down. It comes back down. It should be a bit clear. What do you mean by it comes back down?
Like it heads towards the origin with a constant velocity.
So it returns to its starting point.
Yes, with a constant velocity.
With that constant velocity. Yes, fantastic contribution. So this is during the time interval T1, body is in uniform what?
Accelerated motion.
Good, accelerated motion. Then between T2 and T1,
constant
velocity.
This is constant velocity, meaning acceleration is 0. Okay, constant velocity. Then between T3 and T2, we have uniform what? Uniform what?
Decelerated motion.
Decelerated motion or deceleration. Good. Then from 0 to T1, we have uniform velocity. Velocity motion. Over here, body is at rest. Okay. Body is at rest. At rest. Then uniform velocity again, motion, but it is returning to its starting point. returning back to its starting point. That's the difference between these two graphs. Now, we have this kind of motion. The body is a velocity time graph. This is 20. Body goes through uniform acceleration, and at time, this is 5 seconds. That's this. And then goes through uniform deceleration after 5 seconds, so this is 10. Then this is 12 seconds. This is 11. This point is equal to -8 because it's below the zero. This is -8. Class, your work is that calculate the total distance covered. Okay, or let me even add something to it. Calculate the acceleration of the body, the acceleration during the motion, or let me modify it a bit so that you are not confused. Calculate the acceleration during the first 5 seconds. 2, the average deceleration. And 3, total distance covered. And finally, the total displacement. All right, start work. 6 minutes to attempt this. So there's the motion. The time is given. It's a velocity time graph. It's a velocity time graph. I want to modify. Calculate the acceleration during the first 5 seconds, the average deceleration, total distance covered, and then total displacement of the body. Whoever gets everything correct wins a traveling visa to Dubai after COVID.
So should we send the answers to you?
No, we'll discuss it. Okay. So when you get it right, okay, you see, because we'll be marking ourselves. You'll be marking. 2 minutes more. 2 minutes. One minute. Nhyira kwa atema. Okay, your time is up. Class, time is up. Let's discuss it. Okay, so 1, calculate the acceleration during the first that means we are discussing. So as I solve it with you, you'll be marking yourselves, okay?
Okay, sir.
So during the 5 seconds, this is it. The body went through uniform acceleration. Uniform acceleration. In the slope of a velocity time graph would give you the acceleration. So let's find the slope. The slope here is a change in. Oh, hello, did I give you values here? Did I give values here?
Yes, sir.
Yes, please.
What's the value?
20.
What's the value?
20.
20.
Okay. So 20 minus 0 over 5 seconds interval. So the acceleration will be 4 meters per second squared. Please, did you all get that? Did you all get that correct?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Yes,
then
sir.
start marking. The average deceleration. The word average deceleration means the effective deceleration during the whole motion. And the deceleration only occurred between the time interval 10 seconds and 11 seconds. So the slope of this, hello, Maxwell. Hello, Maxwell, your hand is up.
Step wanted I got it correct.
Okay, yo. So the average deceleration is also equal to the slope, okay, during the time in the interval between 11 seconds and 10. So final velocity 0 minus initial velocity, which is 20, all divided by a time interval of 1 second. 11 minus 10, 1. So the average deceleration is also 20 meter per second squared. If you have negative there, you are not wrong. Or negative 20. I hope you got that as well. Class, did you get that?
Yes,
correct?
sir. Yes, sir.
Yes.
Yes,
Yes.
sir.
All right.
No, sir.
And so if you didn't get it, please correct it. Okay, this is initial velocity and final velocity during this time interval, 10 seconds to 11. Then the third part, the total distance. I said the area under a velocity time graph is equal to the total distance traveled. Now, it made some movements over the positive values, y and x, and also made some movement over the negative. So we have a certain distance covered up and a certain distance covered downwards. Since distance covered doesn't care about direction, we look for the total distance along up the horizontal. Look for the total distance down the horizontal and add them. That will give us the total distance. Up the horizontal, we have a trapezium. So we know area of a trapezium is equal to half times the opposite parallel size times the height. This point and this point would give us A. From this point to this point would also give us B. H is that length which is perpendicular to both A and B. This is it, or this part. So this is H. Either you pick this one or this one. Now class, what is A? What's the value of A? Looking at the graph, what's the value of A?
5.
5, good. So 5 plus, what is B? Frida, go ahead. What is B?
10.
Sir, please, can you take it over again?
So this is A. The two parallel sides, we have this side and then this side. The trapezoid shape. This is the trapezoid shape. So B ends here. It starts from here and ends here. Whereas A also is between these 2 points. So A is equal to 10 minus 5, which is 5. What about B? What's the value of B, class? Evans, go ahead.
11.
11.
Please, 11 seconds.
Good. Then what is the value of the height? What's the value of H? Darius.
Sir.
Darius. What's the value of H? H is 20.
I was going to
right?
ask how was B11, but I've seen it.
Okay. So we have half times 16 times 20. 2 would go into this, yes, 10. So we have 160 meters covered up. Then we find the area of the shape, okay, here, which is a triangular shape. So area of a triangle is equal to half base times height. The base is this side. The base is this side, and the height is also here, h. So the base is equal to 1, whereas the height is equal to 8. We are considering the magnitude of the height. So ignore the negative is just because it's below the 0. Okay. So this is also giving us a total of 4 meters. Therefore, total distance covered is equal to 160 plus 4. This the distance covered above and then the distance covered below, totaling 164 meters. How many of you got this correct? Show by hands. If you got this part correct, show by hands. Pascaline got it. Oh, okay. Camila also got it. And then, okay, Perez. Zion also got it right. Okay. All right. Jonathan, JJ got, okay. Dennis, right. Now let's look at the total displacement. You see, Darius, is it a question?
Yes, sir.
Okay, ask.
So, please, I don't get how you were able to do the area.
You see, the total distance covered has to do with the area under the whole graph. That's why I've shaded the graph. Originally, this is the graph. Originally, good. This is the graph. So if I want the area under the graph, it is all the area below this straight lines, this and that. So that's why I'm shading below the line, which represents the motion of the body. So up here, yes, and then that's not all. There is also another area above here. So up the graph, we have the shape of a trapezium. Below, we have a triangle. And total distance doesn't care about direction. So you find the area, this area here, and add it to this area here, and you have the total distance traveled by the body. Are you okay? Now, displacement, on the other hand, respects direction. So how do we determine the total displacement? Motion above the positive line are positive. So these motions up here is regarded as positive. Motion below this, negative. So above we had positive 160. Below we had 4, and that is negative 4. So total displacement, this time you consider the direction. 160 above plus minus 4 below. And this would give us 160 minus 4, which is 156 meters. So this is the total displacement. Class, are we okay?
Yes, sir.
So
Yes,
for
sir.
displacement, you look for positive area above, the total distance above, and then the total distance below the x becomes negative. You subtract and you are good to go. All right. So how many of you got this correct? the displacement. I doubt if this time around I can have anybody getting that right, but it's a knowledge, okay? Hey, Wilson, are you sure?
Yes, sir.
Then that's
So
great.
I got the same for the distance and the displacement, and I just placed the value there.
Okay. All right. Okay. All right. Then it's good. Some of you managed to get this right. Okay, then let's move on. Evans, is it a question?
Yes, please.
Okay, go ahead.
Sir, please, at first you wrote -8.
Where?
The graph. I'm talking about the graph. Below the 0.
And that is -8, but when you are calculating, you use the magnitude. It is negative just because it's below 0, but the magnitude is 8.
Okay.
Okay, that is why when I was finding the area, the height, I use 8. You consider the magnitude. But when you get the area, because the area is below the graph, you consider the area to be a negative. That's why it is subtracted from 160.
Okay.
All right. Let's move on to equations of motion. We have represented motion on a graph. And now we are going to use equations to describe the same thing. And it is interesting that when you use this and the graph, you must get the same values. So after going through it, we'll give ourselves question, represent it on a graph, and then use the equation. And you see how beautiful it is to master the two. Now, equations of motion lies or hinges on a condition. The condition for using the equations is that you must have a uniformly accelerated motion. So the equations only apply to uniform accelerated motion where the rate of change of velocity or speed with respect to time is constant. Meaning if you have a motion where you have irregular velocity, you cannot use the equations. So take note. So considering a body okay, is it Viveka? I don't know if I've mentioned your name correctly. Your hand is up. Viveka,
Yes,
is it? Do you have a question?
Yes, please. Sir, please, can you repeat what you said again?
The condition for application of the equations of motion we are coming to derive only hinges on uniformly accelerated motion. Uniformly or uniform accelerated motion, meaning that for such motions, the rate of change of velocity with respect to time must be constant or uniform. So considering a body of initial velocity u and a final velocity v, having covered a distance s within a time interval t. So we are actually looking at a body starting a motion where its initial velocity is u, final velocity v. Okay, final velocity v, having covered a distance s within a time interval. So we can even represent it here. A body is moving. Its initial velocity is this. It covers a certain distance s using a time interval t. That is the final velocity of the body. If I ask that we determine the acceleration of this body, how do we calculate the acceleration of the body? If these are the parameters of the body, how do we determine the acceleration of the body? Okay, Ivan.
Sir, please. A is equal to V minus U over T.
Thank you. So A, acceleration of the body will be equal to final velocity minus initial velocity divided by T. Please help me make V the subject. From this equation, help me make V the subject. Viveka, do this for me. Viveka, I'm waiting for you.
Yes.
Yes. Help me make V the subject. Okay,
You multiply through.
Okay, let Jedediah also come in.
Okay.
V will be equal to acceleration times time plus initial velocity.
U. So, okay, Jeremy, yes, it's been answered. So rearranging it, V is equal to U plus AT. This becomes the first equation of motion, linear motion. Equation 1, the first equation of linear motion. Are we okay? Now, if we want to find the average velocity of the body, we are interested in the average velocity. Average velocity means the effective velocity during the whole motion. Average velocity is the effective velocity. This can be shortened as V with a bar on the head, or just V subscript AV, average. So V bar or VAB represents average velocity. Average velocity can be determined as or calculated as the total distance covered divided by the total time taken. So if the body moves in such a way that it covered a distance S, the total distance becomes S. It covered the distance using a time interval T. So the average velocity can be as total distance over the total time. Okay, this is star, one of the equations for determining average velocity. Another way we can determine average velocity V bar is that if you have two numbers A and B and you are asked to calculate the average of these two numbers, how do you do that? You have A and B, calculate the average or the mean of these two values. How would you do that? Yes, Aram.
You should add the two numbers and then divide it by the number of numbers, which is 2.
Good. So the same way, the average velocity here can also be the initial velocity plus the final velocity divided by 2. This will also give us the same value as average velocity. So this is also star. They all represent average velocity. So if this is average velocity and this is also an average velocity, then I can equate total distance over total time to u plus v over 2, because they are all average velocities. Class, are you okay here? Are we fine here?
Yes.
Yes.
So we are looking at two different ways of determining average velocity. It can be total distance covered. So when the body moves from this point to this point, it covered a distance s. What's the time taken to cover the distance? T. So the average velocity or the effective velocity during the motion can be total distance covered as divided by the total time taken, T. So that is the first equation I have here. Okay, equally, we can calculate average velocity using the concept of determining the mean or average of two or more values. If I give you A and B, the average value of the numbers can be a sum of the numbers involved. We have only two of them. So A plus B divided by, because they are 2, divided by 2. Don't forget, if it is 3, it will be divided by 3, on and on. So we have two velocities, U, initial velocity, and final velocity. So the average velocity can also be summing the two velocities and dividing by their numbers. Please, I hope that's okay.
Yes.
Okay. So because the two are all ways of determining average velocities or effective velocities, we can equate them S over T to U plus V, and that's what I've done here. Don't forget, they are all V bar or V subscript average. Meaning, from this equation, if I make S the subject, I have U plus V all divided by 2 times T. The moment you understand that the concept of average velocity, you can easily use this to determine equation 2 and equation 3. So we say that this is the engine of equation 2 and 3. Let's see how we can apply it. So the engine of the average velocity 10 is the engine of equation 2, the second equation of motion, and the third. Class, right? Copy quickly so I flip to the next page. I'm waiting for you. Are you done writing?
No.
Let's hurry up. Let's continue. We have less than 15 minutes to go. So if S over T, average velocity, this is also equal to U plus V over 2, and S is equal to U plus V all on 2 times T. Now, in the first equation of motion, we have V is equal to U plus AT. In this equation, wherever you see V, come and substitute this. Okay, in the average velocity equation, which is this, wherever you see V, substitute this in place of V. Substitute U plus AT in place of V. So please note carefully. S is
Sir,
equal
please, can you
to,
repeat it?
so in the average velocity equation, I said the engine of equation 2 and 3, which is this. If you make S displacement the subject, you get this. Are you okay? You get U plus V all on 2 times T. Are you okay?
Yes, sir.
Yes. Wherever you see V, go and substitute equation 1. And this is equation 1. Wherever you see V in this engine, come and substitute this. I'm doing that with you. So S will be equal to U plus this V. I'm going to substitute U plus AT all divided by 2 times T. Please, are you okay here?
Yes, sir.
Good.
Yes.
Then simplify
Yes,
it.
sir.
If you simplify, U plus U is 2U plus AT all divided by 2. Don't forget to put this, still put this in brackets and multiply it by the 2 outside. Divide the numerator by the common denominator 2. So 2U divided by 2 plus AT divided by 2. Whilst we have the T outside multiplying it. You see that 2 would cancel this. So we have S is equal to U plus AT, this on 2 times T. Are we okay? Are we okay up to this point?
Yes,
Yes,
sir.
sir.
Yes, sir.
So the next step is that multiply through by the T outside the bracket. So if I multiply this by T, I have UT plus T times this, I have AT squared over 2. This is the same as UT plus half AT squared. This is equation 2. This is equation 2. Equation 3, the same engine. If S is equal to U plus V all on 2 times T, in the same equation of motion, the first equation of motion, which is V is equal to U plus AT, make T the subject. Make T the subject. Somebody should help me. Dennis, help me make T the subject.
Sir, please, first you send the sir, please should I just say the answer?
Yes.
Okay, sir. Sir, please, T is equal to V minus U all divided by A.
Exactly. So within this same equation, come and substitute V minus U over A, all over A, in place of T, the T here. So if I do the substitution, I have S is equal to, don't forget S is small letter displacement. S is equal to U plus V all on 2 into brackets. I'm replacing T by this. V minus U all on A. And the numerator would give us a kind of difference of 2 squared. Okay, A minus B times A plus B is equal to A squared minus B squared. So we have similar situation here. V minus U times V plus U must give us V squared minus U squared. So the numerator of this would give us the difference of 2 squared, which is V squared minus U squared divided by the numerator 2 times A, 2A, Farida.
Sir.
Mm-hmm.
So please, can you take it again from S is equal to
So this is what we have from here. We have S is equal to U plus V all on 2 times, Abbas, I'm coming, times V minus U all on A. So numerator times numerator, denominator times denominator, isn't it? So we have V plus U times V minus U divided by 2 times A. So the numerator would give us V squared minus U squared divided by denominator 2A. And that's what I've done here. Farid, are you okay?
Yes, please.
Abbas, are you okay?
Yes, sir.
Is it yes or no?
Yes.
Okay. So from this equation, help me make V squared the subject. Help me make V squared the subject. From this equation. Or make V squared the subject and share it with me by telling me afterwards. Make V squared the subject. Jedidiah.
V squared equals 2AS plus U squared.
Or when you rearrange it, V squared is equal to U squared plus 2as. This class, this is the third equation of motion, and we are done. Sometimes other books will quote a certain fourth equation. The fourth equation is not anything but the average velocity equation. S is equal to u plus v all on 2 times t. This is what other books quote as the fourth equation. But the three main equations, equation 1, v is equal to u plus at. Equation 2, s is equal to ut plus half at squared. And equation 3, v squared is equal to u squared plus 2as. These are the three equations used for accelerated, uniformly accelerated motions. Meaning, if the motion is not uniformly accelerated, ladies and gentlemen, you cannot use them. Any question? Yes, Abbas.
Sir, so please, do you have formula for finding for non-uniform accelerated motion?
At your level, we don't worry ourselves. At the SHS level, we don't worry ourselves with non-uniform accelerated motion. This is our concern at your level, okay? So
Okay.
when you grow up, you'll be introduced to that dimension of motion as well. Is there any other question? All right, our time is up. So as I said, please form your assignment pages. I'll send you work sets. Okay, do it and then send it to me for marking. This time around, if I mark your work, I'll update it on the page. So if you don't do it, your mom, your dad, your grandparents can be able to determine that you are not a doer of assignments. So I beg you, form your pages and do that for me, okay? Alexandra.
Sir, please, what's the deadline?
Oh, I'll state the deadline on the questions. So don't worry. The line
So
will
please, your
actually be
number
there.
for the group.
Oh, my number is 024-096, another 0965. 024.
Sir, please come again.
024-096.
Okay.
Another 096.
096.
5.
096.
Okay, yes, 5. Please, if you go to the page, subscribe, and then you can be sharing, okay, the video so that we grow the channel, okay? Until then, may the good Lord be with you. Take care of yourselves and bye-bye.
Sir, please, will you send us?
Bye.
Yes, I'll send this video.
Sir.
Yeah, hello.
Okay.
Okay, bye-bye.
Hello.
Yeah, I'm here. Darren, I'm here.
So please, you send the recording of the video, the Zoom meeting.
I've been doing that. I've always been doing that. Don't worry. Please do not write on the page. Okay, others are writing, so stop doing that. Enoch, stop doing that. Wilson, I've caught you. Okay, Komla, I'll send it, so don't worry. All right, but hello.
Your number again.
024. Oh, I'll send the video, so don't worry.
Okay.